Electric network elements, power transmission and distribution. In this video, we'll talk about transmission and distribution of electrical energy from generation units to consumers, while emphasizing some of the limitations and constraints associated with network operation. At the end of this video, you will be able to identify basic components of transmission and distribution networks, describe some of the constraints and limitations of the network, describe the impact of newly introduced loads on operating conditions, and describe potential solutions to the introduced problems. In conventional electrical networks, electrical energy is generated in power plants, and then transmitted and distributed through transmission and distribution networks to end consumers. The main goal is to maintain reliable and secure supply of electrical energy to consumers while reducing operational costs. In many cases, power plants are not located near heavily populated areas. Therefore, electrical energy has to be transmitted over long distances through transmission networks. Power transformers are used to step up the generator terminal voltage to higher levels, such as 110 kV and higher. Transmission lines connect generation units with distant substations. Mesh topology is typically used to ensure reliability and redundancy in case of network failures. Furthermore, additional redundancy is achieved by interconnecting multiple transmission networks from neighboring countries that altogether form an international transmission system. The transmission network must be designed to withstand disconnection or malfunction of any element in the system without interrupting the supply and maintaining adequate power quality. Power transformers at substations closer to populated areas step down voltage, typically to levels below 110 kV, which indicates the beginning of distribution network. Distribution network supplies bigger industrial consumers and many low-voltage networks in the area. Electrical energy is distributed through overhead lines and underground cables to urban and rural areas. Distributed generation, such as solar power plants and wind turbines, are commonly connected across distribution network and can cause higher voltages in the network with insufficient observability and controllability. Protection devices, switching equipment, and meters are also among the crucial components of the network that ensure safe operation of the network and enable network management. To allow network management and to increase observability of the distribution network, integration of measuring equipment and communication network is necessary. In modern distribution networks, new types of loads with higher nominal powers, such as electric vehicles and heat pumps, are increasingly being connected. Due to their stochastic behavior, their consumption is not predictable and can cause damage by overloading network elements like transformers and power lines and increase network losses. Each network element is designed to operate under nominal conditions to achieve its expected lifetime. Peak network demand can surpass nominal power of the transformer. For instance, all owners of electric vehicles in the neighborhood start to charge their vehicle at the same time. This could cause additional heating of the transformer winding, which can later lead to faster insulation degradation. If not handled in a smart way, overloading is avoided by upgrading the network with transformers with greater rated powers. Similarly, when the current going through power lines surpasses their rated current, they have to be replaced with ones that have larger cross-sections. To avoid huge investments, overloading can be mitigated by controlling the loads that are causing problems in a smart way. The main goal is to move their consumption to parts of the day when network demand is lower. Some of the possible solutions are smart charging and implementation of vehicle-to-grid concept, smart control of heat pump consumption, and integration of batteries in the network. To conclude, new loads, such as heat pumps and electric vehicles, can lead to new and partly unpredictable consumption patterns that can cause overloading of some elements in the network. On the other hand, distributed generation can cause overvoltages in networks with insufficient observability and controllability. In terms of investments, planning and dimensioning network to satisfy the highest requirements is, in some cases, not economically feasible. Therefore, smart solutions can be implemented to solve a problem of overloading. Thanks for watching.